Okay, good evening. We are looking at our last objective of the third unit, which is going to be graphing linear functions, right? So, we've spent almost the whole unit talking about functions that get written in this form. F of x equals mx plus b, right? Of course, we've said this 100 times. That's the rate of change. That's the y-intercept. Now, when we go to actually graph these functions, we've done this before using a table of values. So if we had the function y equals, or f of x equals 2x plus 1, right? Well, what we would do is we would make a table, right? So for an input of 0, we get an output of 1, right? So we plot that point, 0, 1. Okay. For an input of, say, 1, right, we do 2 times 1 is 2, plus 1 is 3, which gives us an output of 3. And for an input of 2, we get an output of 2 times 2 plus 1 is 5. And, we can plot as many points as we want, right? But what we see is that we get a straight line. So let me quickly show you what that line looks like. Well, it goes through here, and then it goes on forever, right? Because we could put any number into this equation. So we'll just make a straight line that would go on forever. And just to indicate that it's going to go on forever, we can make a couple arrows on the end, right? So, this process is fine, but it turns out that there are some challenges that are associated with it when we get into fractions. But a couple things that I want you to see about this line. First of all, we know that the slope of the line is 2, right? So we know that when x goes up by 1, y goes up by 1, 2, right? Then we do it again, right? X goes up by 1, y goes up by, as soon as I get there, y will go up by 2, right? So, that's how we use the slope to find the next point on the line. So if I'm here, right, I could go down 2 and left 1, right? So if x goes down by 1, that wasn't too well drawn, the y goes down by 2, and so on. So that's a visual interpretation of slope. And the other thing that shows up is the y-intercept, right? So we're going to cross the y-axis at 1, which comes right from there. So we can actually use this method to graph any linear equation. So let me get rid of all this stuff that we just did. And now I'm going to show you how you can use the slope and the y-intercept to graph say, this function, right? So it looks like it won't let me undo it anymore. Okay, so we've got this function here. Now my slope, which I represent with the letter m, remember, slope is always change in y divided by change in x, right? So the change in y here is 1, right? Because that's on top of the fraction. So it's 1, and the change in x is 3. Okay, so what that says is when x changes by 3, right? When we go 3, we go 1. All right? And the other point is that my y-intercept, I know right away, is negative 2. So when I go to graph this thing, right, first of all, I know that it has positive slope, okay? So let me just kind of draw this on the side for you. Any line with positive slope, right, goes, as x increases, y increases, okay? Or another way of thinking about that is as x decreases, y decreases, okay? So this is positive slope. And we made it 4 minutes without that happening. So progress, right? So this is positive slope, okay? So all I have to do to graph this line is I need to start at my y-intercept. So I know that the line has to pass through here, right? All right, so look at this. I'm going to change x by 3, right? So that means I'm going to start here, and I have my x direction, so I'm going to go 1, 2, 3, right? So that says the change in x is 3. The change in y is 1, right? So, and I can do that again, right? From here, to find the next point, I'm going to go 1, 2, 3, 1. 1, 2, 3, 1. Now, this is enough points to graph the line, but I can also go the other way. If x goes down 3, y is going to go down 1. Okay, here we are. Oop. If x goes down 3, y goes down 1. Now, we don't need to graph all those points, right? Just a few will do. But clearly, we see now that we get a straight line that passes through all of these points. Okay? So this here is the function that we're talking about, right? So this function here is f of... Oops, let's get back to my drawing tool. So here, the function is f of x equals 1/3 x minus 2, right? So look, we're down here, starting at the y-intercept, we go over 3, up 1, over 3, up 1, over 3, up 1, and that's the graph of the function. Now, we could have gone and made a table of values, but it would have taken longer. This requires us just to know the slope and the y-intercept, okay? So now let's look at another example. So this line here, we see right away that the slope is negative. So what we can do is we can think about this, right? So, you know, obviously negative slope will have to look different than positive slope. So positive slope goes up and to the right. Negative slope is going to go up and to the left, right? Or, same idea, down and to the right. So that's negative slope, okay? So when you graph the line, I'm going to say negative m. When you graph the line, it should look like this if it has negative slope. Now, the change here, right, let's think about this. The change, right, we have change in y divided by change in x. Well, the change in y is negative 2. Well, negative 2. The change in x, even though it's not written there, another way of writing negative 2 is just negative 2 divided by 1, right? Same number, negative 2 divided by 1, the same as negative 2. The only reason we're doing that is so that we can clearly see that when x changes by 1, right, so when x increases by 1, y is going to decrease by 2, okay? And of course, my y-intercept here is at positive 4. Okay, so now I can go ahead and graph this thing, right? So I'm going to start up here at the y-intercept of 4. Okay, so look, I'm going to increase x by 1, right? Using my change of x. Change of x is 1. Okay, so I increase x by 1, and then I'm going to decrease y by 2. Okay, and that's what the slope's telling us here, right? X goes up by 1, y goes down by 2. X goes up by 1, y goes down by 2. X goes up by 1, y goes down by 2. Okay? Now, if we think about it the other way, right? If x goes down by 1, y has to go up by 2, right? Because this thing should be a line. And there's that line that we're talking about, which is now obscured because of my mistake. But, you know, it works both ways, right? Let's see. Up by 1, down by 2. Down by 1, up by 2, right? So we make a line. Let's keep going here. Up by 1, right? Change in x is 1. Change in y is 2. Ooh, and there's a perfect little line that goes through all the points, okay? So this line here, this function, is still f of x, or maybe we should call it g of x, but I wrote f of x. So f of x equals negative 2x plus 4, okay? So let me just show you really clearly what's happening here, right? So, you know, we're here, or start at the y-intercept, right? If x increases by 1, that's my change in x, okay? My delta x. The y goes down 2, right? Here's my change in y. So the change in x is 1, right? That's one space. Change in y is negative 2. Well, let's see how that looks on this line here. Okay, let's switch back to green. Watch. Well, my change in x, let's actually go over to this point. It'll be easier to see. My change in x is 1, 2, 3. Change in x equals 3. And then here, my change in y, as soon as I get there, change in y is equal to 1, right? And that matches our slope formula, right? Our slope formula says that the change in y divided by the change in x has to be 1 divided by 3, right? So the change in y is 1, change in x is 3. Same idea here, okay? So if you really think about this, you should be able to graph any line. All you have to do is start at the y-intercept and then use the slope. So you have a few practice problems to try. If you have any questions, let me know, and hopefully we can attack this in class later. That's all for me. Thanks for watching.